In my previous video, we have discussed Euler's method. In this video, we will discuss Euler's modified method. We have a differential equation dy by dx equals f of x comma y, whose solution is y equals fx. We will draw the solution of this curve and represent the solution of this differential equation by this curve. We will take point P x0 y0 on this curve y equals fx. We will draw a tangent t1 to this curve whose slope m1 will be according to this f of x0 y0. Then we take point q on this curve whose x coordinate is x1, where x1 minus x0, which is h, is extremely small. Let the vertical line qx1 cuts the tangent at point S, whose coordinates will be x1, y1. For very small value of h, curve PQ will be approximately equal to straight line PS. Therefore, y coordinate of Q will be y1 and given by y1 equals y0 plus h times f of x0 comma y0 according to Euler's method. In modified Euler's method, what we do is we draw another line through S1 called T2, whose slope M2 will be f of x1 comma y1. We will draw another line through S called T, whose slope M is the average of slopes of T1 and T2, that is f of x1 y1 plus f of x0 y0 upon 2. Now we will draw a line parallel to T passing through point P called line PR, whose slope is M, same as this. We will extend vertical line x1q to cut line PR at say point B. Since h is very small, y coordinate of point B y1 can be considered as the y coordinate of point Q. We will write equation of line PBR according to slope point form. Y minus y0 equals this slope m times x minus x0. That will be first approximation of y1. That will be y1 1 equals y0 plus x minus x0 is same as x1 minus x0, which is h. So here y0 plus h times this slope m, which is f of x0 comma y0 plus f of x1 comma y1 upon 2. For the second approximation of y1, we write y1 2 this y0 plus h times f of x0 comma y0 plus f of x1 comma y1 from the first approximation, so we write 1 here. We will continue this process until there is no difference between two successive approximations. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Now let's revise what we have done so far. We have drawn this solution curve and a tangent T1 at x0, y0. Then we took a point Q very close to P, whose x coordinate is x1. Distance between x0 and x1 is h. This is the point S on the tangent T1. We get this error h times f of x0 comma y0 in Euler's method. So the y coordinate of Q, y1 is this y0 plus this error h f of x0 comma y0. In Euler's modified method, we try to reduce this error by drawing another line t2 closer to the curve with slope m2 f of x1 comma y1. The slope of t1 already is f of x0 comma y0. Here we draw a line through S T, whose slope m is average of these two slopes, that is f of x0 comma y0 plus f of x1 comma y1 upon 2 and draw parallel to this t through P and which cuts the curve at R. Vertical line through Q cuts this PR at say point B. Now here QB is the new reduced error h times this slope m, so that we get better approximation for this y coordinate of point Q. In the first approximation we call this y1 as y11 equals y0 plus h times f of x0 comma y0 plus f of x1 comma y1 upon 2. This is first approximation of y1. For the second approximation of this y1 we write y12 equals y0 plus h times f of x0 comma y0 plus f of x1, and here for y1 we substitute this value of y1 1 upon 2. We continue this process of approximation until two successive approximations are the same, meaning this is the closest approximation to the true value of y1. We have to use Euler's modified method to find value of y for value of x equals 0.1 from the differential equation dy by dx equals y minus 2x upon y. We are given that value of y when x equals 0 is 1 as the initial condition, and we have to take step size h equals 0.1. Now from this we have f of x comma y equals y minus 2x upon y. Then x0 is this 0, y0 is this 1, then h is 0.1. Now y1 according to Euler's method will be y0 plus h f of x0 comma y0. So that will be y0 is 1 plus h is 0.1. F of x0 y0 will be y0 which is 1 minus 2 x0 is 0 and y0 is 1 again. So that will be 1 plus 0.1. So we get y1 equals 1.1. Now we write the first approximation y1 of 1 equals y0 plus h upon 2 f of x0 comma y0 plus f of x1 comma y1. That will be y0 is 1 plus 0.1 upon 2 f of x0 y0 will be 1 minus 2 into 0 upon 1 plus y1 which is 1.1 minus 2 x1 which is this 0.1 upon y1 which is 1.1 again. So that will be 1 plus this 0.05 multiplied by 1 plus this 1.1 minus this part will be 0.1818. So that finally gives us y1 of 1 equals 1.0959, which we have to use in the next approximation. So we write the second approximation y1 of 2 equals y0 plus h upon 2 f of x0 comma y0 plus f of x1 comma this y1 of 1. So that will be plus f of x1 y of 1 will be y1 which is this 1.0959 minus 2 into x1 which is this 0.1 upon y1 which is this 1.0959. So that will be equal to 1 plus 0.05 multiplied by this 1 plus 1.0959, that will be 2.0959 minus this calculation which will be 0.18250, that will be 1.09567, which finally y1 of 2, that is of second approximation 1.0957, which we have to use in the next approximation, that is third approximation. In the third approximation we write y1 of 3 equals y0 plus h upon 2 f of x0 comma y0 plus f of x1 comma y1 of 2, that is the value of the second approximation. So next we write 1 plus 0.1 upon 2 f of x0 y0 is 1 minus 0 plus f of x1 comma y1 2 will be 1.0957 minus 2 times x1 0.1 upon y1 from 2 1.0957, that will be 1 plus 0.05, this will be 2.0957, and this will be minus 0.1825, so that will be 1.09566. So the third approximation of y1 will be 1.0957, which is same as second approximation of y. Since the second approximation and third approximation of y1 gives same value up to 4 decimal places, correct value of y at x equals 1.1 is y equals 1.0957. So this is how we can use Euler's modified method to find correct value of y at a particular value of x. In the next problem, we have to determine the value of y when x equals 0.1, given that y of 0 equals 1 and a differential equation dy by dx equals x square plus y by Euler's modified method, also known as Runge Kutta method of second order, correct up to 4 decimals, taking h equals 0.05. Since we have to find y when x is equal to 0.1 and since the step size is 0.05, we will do this in two stages. In the first stage A, we will take x0 equals this 0, y0 equals this 1, h equals 0.05, x1 equals, we will find y1 according to Euler's method. So y1 equals y0 plus h f of x0 comma y0. So that will be y0 is 1, h is 0.05, f of x0 y0 will be 0 square plus 1, so that gives us 1.05. So we use this y1 in Euler's modified method. Accordingly, the first approximation will be y1 of 1 equals y0 plus h by 2 f of x0 comma y0 plus f of x1 comma y1, that is y0 is 1 plus h is 0.05 upon 2, f of x0 y0 is 0 square plus 1 plus f of x1 y1 will be 0.05 whole square plus y1 is 1.05. This will be 1 plus 0.0507. So after first approximation, y1 of 1 will be 1.0507. We will use this value of y1 for the second approximation. Second approximation gives y1 of 2 equals y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma the first approximation of y1, that is y1 of 1. So we write 1 plus 0.05 upon 2, f of x0 y0 is 1 plus f of x1 y1 of 1 will be x1 is 0.05 whole square plus y1 of 1 is 1.0507, that will be 1 plus 0.0513. Hence y1 for the second approximation will be 1.05. We will find the third approximation of y1, which will be y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma this y1 of second approximation. So that will be 1 plus 0.05 upon 2 f of x0 y0 is 1 plus f of x1 comma second approximation 0.05 whole square plus the value of this second approximation 1.0513. So that will be 1 plus 0.0513, that will be 1.0513, which is same as this value. And since second approximation of y1 is same as third approximation of y1, which is 1.0.13, we conclude that value of y when x is 0.05 is 1.0513 up to 4 decimals. We have to find y when x is 0.1, and we have here value of y when x is 0.5, which is 1.0513. Now we will use this value as the initial x value, which is x0, and this value as the initial y value, y0. And we will first find out y1 from Euler's method, which is y0 plus h f of x0 comma y0. So that will be y0 is 1.0513 plus h is 0.05 multiplied by f of x0 y0 will be x0 square, that is 0.05 whole square plus y0, which is 1.0513. So this new y1 will work out to be 1.10399. So we will use this x0, this y0 and this y1 for the second part to find value of y when x is 0.1. Now in the second part B, we have x0 equals 0.05, y0 equals 1.0513, h equals 0.05, x1 equals 0.1, and y1 equals 1.10399. Now for the first approximation, we write y1 of 1 equals y0 plus h upon 2 f of x0 comma y0 plus f of x1 comma y1, that will be 1.0513 plus 0.05 upon 2. F of x0 y0 will be 0.05 whole square plus this 1.0513 plus x1 square 0.1 square plus y1, which is this 1.10399, which will be 1.0513 plus 0.054195, that gives y1 of 1 as 1.10545. Now we will find second approximation, that will be y1 of 2, that is y0 plus h by 2 f of x0 comma y0 plus f of x1, and here first approximation of y1, so that will be 1.0513 plus 0.05 upon 2. F of x0 y0 will be 0.05 whole square plus y0, which is 1.0513 plus f of x1, that will be 0.1 whole square plus first approximation, which is 1.10545, that will be 1.0513 plus the remaining calculation 0.05423, that gives us second approximation y1 as 1.10553. We have second approximation of y1 to be 1.10553, which we will use to find the third approximation, which will be y0 plus h upon 2 f of x0 comma y0 plus f of x1 comma this second approximation of y1, that will be 1.0513 plus 0.05 upon 2 multiplied by f of x0 y0 will be 0.05 whole square plus y0, which is 1.0513 plus f of x1 comma second approximation of y1 will be 0.1 whole square plus this second approximation, which is 1.10553, that will be 1.0513 plus the remaining calculation, which works out to be 0.05423. That gives us the third approximation of y1 to be 1.10553, same as the second approximation of y1. So therefore we conclude that the correct value of y is 1.10553 when x is 0.1. So this is our answer. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.